Alright, in this video I will be solving problems 42 through 45 which deal with exponential equations and logarithmic equations. So first of all, we have two major techniques that we use when we solve exponential equations. One is what I call the equal bases method. If I can write each side using the same base, then I can use this approach. So notice I'll leave the left side alone, and I can write 125 as 5 cubed. So if I have two powers of 5 that are equal, the only way that could be true is if the exponents are equal. So 4x minus 7 must equal 3, which means 4x is 10. Divide by 4 on both sides, we get 10/4, which reduces to 5/2. So that's the equal bases method. Now we don't have one of these, but the other main technique we used was where we switch forms. I should say we don't have one of these right here, but that was if you had something like 2 to the x power equals 17. You can't write 17 as 2 to a power, but so what we do is we switch forms. And in fact, anytime you have a variable in the exponent and you're dealing with an exponential equation, you're going to have to switch to the logarithmic form. So this is log base 2 of 17 is equal to x. Remember, it's 2 to the x power is 17. It's base, exponent, answer when you're in log form. And we could write this using the change of base formula. Whoops. It's the log of 17 over the log of 2. And let me plug that into my calculator. You get 4.0875. And the nice thing about these is you can check them pretty easily. 2 to that power should equal 17. Now we know 2 to the 4th power is 16, so you can see that's just a little more than that. Alright, so that's the switching forms technique, and we talked about equal bases technique. Now for this problem here where we have two different bases, it's a little more challenging and we have a little bit different approach. We're going to take the log of each side. Notice the base is 10 since I didn't write the base. And then we're going to use one of our properties of logs, and we're going to move these exponents out front. So it's x log of 3 is equal to x minus 1 log of 2. Notice because x minus 1 is a binomial, I need parentheses here. I'm actually going to distribute times log of 2. So this will be x log of 3 is equal to x log of 2 minus the log of 2. Now remember, we're trying to solve for x, so we need to get these two terms that have an x in them on the same side. So I'm going to subtract x log of 2 on both sides. So when I do that, I'll get x log of 3 minus x log of 2, and that's going to be equal to minus log of 2. So now we can factor out a GCF of x. We get x times log of 3 minus the log of 2, and that's equal to minus log of 2. So notice I have log of 3 minus log of 2 times x. I can divide both sides by this binomial here, and I'll end up with x equals minus log of 2 over the log of 3 minus the log of 2. And you can plug that into your calculator, and you should get that x is about negative 1.7095. Now if you wanted to check this, you could take 3 to that power and you'll get a number, and then 2 to that power minus 1, so negative 2.7095 power, and you should get the same thing for those. All right, let's move on to the logs. So we're going to be using our properties of logs for these. So let me just write them out here real quick. So that's property 1. And then we have property 2. And property 3. So the product rule, the quotient rule, and the power rule. So you can see we're going to need the product rule here to combine this into one log. And so we have a logarithmic equation. It will be log base 4 of x plus 3 times x minus 3 is equal to 2. So we're basically using this 2 property, but instead of m and m that are multiplied, it's x plus 3 and x minus 3. Now this is the form with the 3 parts of a logarithmic equation. You have the base 4 to the second power is equal to the answer here. So 4 squared equals x plus 3 times x minus 3, or 16 equals x squared minus 9. When you FOIL this out, you get minus 9, x squared minus 9. Okay, so I have only an x squared term, no x term, so that tells me I want to use square root method. So let's add 9 to both sides. We get x squared is 25. Let me take the square root of both sides. Don't forget your plus or minus. You get x is negative 5 and 5. Now the thing we have to remember when we get these answers is we cannot take the log of a negative number. So notice if I plug in negative 5 here, I'd have negative 5 plus 3, which is negative 2. I can't take the log of negative 2. So as soon as I see that that's an issue, I got to throw that answer out. You can see that if you plug in 5, you'd be taking the log of 5 plus 3, which is 8, and that's okay. And the log of 5 minus 3, which is 2, and that's okay. As long as we're taking the log of a positive number, we're good. And now that's assuming you've done everything right. You can check these, but you got to really understand your logarithms to do that. Let's go. The main thing is to make sure that you're not taking the log of a negative. So let's look at 45. Now if you haven't already tried it, you should try it and then watch the video. So this time, because it's a subtraction of 2 logs, we can combine it into one log using property 2 here. So m and m get divided. So it'll be the log base 2 of x plus 20 over x plus 2. And that's equal to the log base 2 of x. So I forgot to mention on number 44, the key step was when we switched from log form to exponential form. So switching forms is one of our 2 types of log problems. The other one's what I call the log equals log case. And that's what we have here. If these 2 logs are equal and they're both base 2 logs, then these inner parts must be equal. And so notice that's different than what we did here when we switched forms. So these are the 2 main types of log problems that you run into. So we have x plus 20 over x plus 2 is equal to x. We'll multiply both sides by x plus 2 to clear fractions. On the left, you get x plus 20. On the right, let's go ahead and distribute. You get x squared plus 2x. This is quadratic equation, and so ideally we're hoping we can factor it. Let's move 0 to one side and everything else to the other. So we'll need to subtract x and 20. On each side, we get 0 equals x squared plus x minus 20. And let me go ahead and move this camera just a little bit. So you should be able to factor that, and when you do, you get x plus 5 times x minus 4, which means x is negative 5 and 4. And again, we have that same problem. Notice if we plug negative 5 in here or here, we'd be taking the log of a negative, so we got to throw that out. You can verify that 4 does work. All right, so that's it for this video. Hope that helps.